Alright, this is made up of wires, and we are decompiling Castlevania Symphony of the Night. Before we get started on decompiling, I wanted to point out a story that made it to Hacker News yesterday, which was, I always like when old video game and decomp stories make it there. This one was about exploiting a bug in Tony Hawk Pro Skater's string copy function to be able to load arbitrary code on an Xbox, and then actually it was ported to GameCube as well, and looks like maybe PlayStation 2. The string copy function is a function that will copy data from one source to another, but it has a weakness that it won't stop until it reads a byte equal to 0 or a null byte, which indicates the end of a string. In this case, that string was controlled by the save file, and so this individual went through and crafted a stack smash attack against Tony Hawk Pro Skater, which then allowed him to run code on a variety of console systems. So that's a pretty cool story. Fun watching somebody decompile a game. In his case, not for the purpose of reproducing that game, but for trying to access the system in other ways. So, what we're primarily doing now is working on decompiling Castlevania Symphony of the Night. Castlevania Symphony of the Night is a game for the PlayStation, PSP, Sega Saturn. It was ported to a variety of systems. Since then, it's on all modern platforms and has been ported a bunch of different places. And so, as part of the decompilation project, we're looking at some of the older versions of the game, trying to get back to sprites and source code that can then be modified and recompiled back into something that will continue to work on the PlayStation or PlayStation Portable. Discover how the game was made, how it worked, and just have fun researching old retro games, especially a game like Castlevania Symphony of the Night. If you want to learn more about this project, you can go to soten.z.dev, which has progress for various objects in the game that are in the process of being decompiled. We're going to be focusing on weapons today. Weapons are about 70% decompiled, so there's some room to go there. There are some objects like stages and the main game, which are either completely decompiled or almost completely decompiled. Recently, the Richter program, which is how the game starts when you're playing as Richter, not only has all of its code been decompiled, but all of the data has been decompiled as well, allowing people to build modifications that allow them to change size of code, size of sprites, and other things like that without having to rely on hard-coded values that are necessary before everything gets decompiled. We're going to be working on weapons. The way decompilation works is we take objects that were originally on the game CD or game download, game disk, use various tools to find out where logical points in those files are. The files that we're looking at contain code. They contain data for that code to look at when running the game, attributes for weapons and characters and enemies, and as well as image and sound data, all combined into a single file. The primary tool used to split those files is called Splat64. It was originally written for the N64 to decompile games there, but it is useful for a variety of games. And so Splat64 is used to take those files, split them out into images, sounds, code, and data, and the code files are then converted into assembly language. That assembly language is the same thing that a C program would produce if you were starting with C code, but we're going in the opposite direction, taking assembly data and trying to convert it back into C code. And that originally was intended to be a one-way translation. I have C code, I want assembly. It was never intended to go backwards from assembly back to C. So there's often some complications, but we have some tools to help us with that as well. The primary tool that's being used to help with that is called Decomp.me. And we can take assembly code from the game, upload it to Decomp.me, and get a decompiled version. To start out with, it's usually not a perfect representation, but it gets us close enough as a starting point. So we need to find a function to decompile. Like I said, we're focusing on weapons. If we go into a project, so this is the source code for the existing, I should go back and say, this project is being primarily worked on as a GitHub community. There's also a Discord channel that you can subscribe to if you're interested. So we have a project set up already. We want to find weapons that have not been decompiled yet. When assembly code is extracted, it's extracted to an ASM directory. We're looking at the US version of the game, looking for weapons. Non-matching are things where we don't have code for those yet, or we don't have code that matches. And we want to look for files that end in .s, which is the extension for assembly files. So we still have a bunch left in here. I actually don't have a clean project at the moment. Give me a second. So we have a clean project that compiles. Now we're going to go look for some assembly to decompile. So files that end in .s. So we have a bunch of them still. We're going to look for the smallest one because that's the easiest to decompile on stream. So we take the size and name and reverse sort by that size. So that'll get us to entity weapon attack 33. I think that's the one that we did yesterday. So we're going to do 31 today, which will be very similar to the one that was done yesterday. So we'll open that up. And so this is what assembly looks like. Assembly is one step above machine code. Often it's thought of as being effectively machine code in a human readable format. It's not very human readable, and it's not exactly machine code either. It's an intermediary step. So we're going to take this, and what we want is to get back to C code that will fit into this file. We have a placeholder here. This include ASM. That's including the assembly, and the rest of this file is in C. We want the entire file to be in C, and to do that we need to decompile that other file. So I'm going to copy this into decomp.me. Here there's several target consoles, as well as different presets for those consoles. So we're looking at code for the PlayStation, and we're going to select the Castlevania Symphony of the Night preset, which has the correct SDK and version of GCC that was used to build the project originally. The context down below is like a header file in C. These are things that are going to be used to assist in the decompiler so that it understands what function signatures look like, what the shape of some structs looks like. I actually don't have my context set up for weapons, for decompiling weapons at the moment, but I did yesterday, so I'm going to use that context. A context can be generated. There's targets in the make file for generating a context for a specific file, but this will, when we create a new scratch in decomp.me, it'll do a best effort attempt at decompiling that source. But it doesn't compile perfectly, and there's certain things that are unknown to the decompiler that we have to help it understand. So the first thing I like to do is get this function to compile. It won't be right, but it'll be working until we get something that can compile. We can't see how close we are to the target assembly that we're trying to get to. Going over the interface, we have a place for the code that we're editing. In this box up here, we have the target assembly that we're trying to match, and then what our current assembly is next to it. And we don't have anything there right now because we're not compiling any code, and that's primarily because this variable is an unknown type. We need to figure out what that type is, so we're going to go through and figure out where it's being used. Some offset here is being taken, and this is being loaded, and this is likely going to be a weapon animation. So I'm going to take a guess. It's going to be an array of weapon animations. And that will help us compile a little further. We still don't have everything compiling yet, so we're going to do a few things to help with that. So this pattern where we have a reference to something plus a value multiplied by a bunch of other things, that is going to be array access. And I know from yesterday that we'll likely have a variable for that access. We'll call that animation index. And that animation index is going to be the param shifted and then masked. I'm not sure if that's the correct mask. I'll have to look at it later on. Okay, so there's still a few other issues before things compile. Mostly it's things related to that temp S1. We have offsets going into that structure, which we know what it is now, and we can actually, before we get going, we can copy that to the context. We know what that is now, so we can decompile again. Now the decompiler will know what the type of those objects is, but it didn't figure it out from that context. Oh, I was hoping it would provide the offsets. It didn't. That's okay. So temp1 is going to be a weapon animation pointer. And so we're just left with these field access where the decompiler shows the wrong values. So we'll go through and fix that up, and we should be compiling. Off screen, I'm going to grab what the definition of that struct is. And we'll paste it up here. So what we're doing down here now is looking for offsets that are unknown. So C is the same as frame start. On line 49, unknown 8 is going to be the palette. 59 is another frame start. On line 60, D is the sound frame. Offset A is the sound ID. Offset 4 is frame props and the frames. And now the only thing that we have left is we can get rid of this struct so that it's not conflicting, and the project compiles. We still have some warnings. We can get rid of those now. In my context, I have some of the built-in functions that GCC provides. String compare, string copy, string length, mem copy. The PlayStation 1 SDK provides those. We don't want to use the ones that are built into the compiler, so we tell it to not use any built-ins, and we'll save our project. This final one we'll get to in a little bit. On line 29, we have an overflow, and we'll talk to that when we talk about it when we get to it. So this is pretty close. There's a few other things to set up before getting started and trying to match entity weapon attack. Any of the entity functions act like class methods in the object-oriented programming language. The first argument is the object that is being worked on. In an object-oriented programming language, we'd have a this or a self variable. We're going to call that one self as a convention for the project and to not overlap with C++ keywords. The next thing is these player macros, or these player globals. Player is actually a macro to the first item in a set of global entities. Whenever this player underscore naming convention is used, it's to give addresses to those to make decompilation easier, but it's not how those things were accessed. So we're not going to use any of these that the decompiler created, or sorry, the Splat64 created when it was extracting. We're going to go through and replace all those with struct access. And this will take a little bit. I had copied those over here, so we want to get rid of those so that we get errors. That'll help us go through and I usually take this time as well to go through and reformat some of this to make it easier to read. Okay, so we're at about 90% similar to the target assembly. The remaining work is really just going through and either matching code. Sometimes it's reordering, sometimes it's finding the correct types for things. But I just continually make passes over the same the function over and over, trying to find common things. Usually it's somewhat systematic, but every once in a while I'll see things here or there that I know can be changed. So I'm going to go through some of these variables now and see what they are. This temp S1, I like to give these things more meaningful names. Temp S1, we're going to call it animation or anim. That's a pretty common convention within the code. This var v0, oftentimes these are not actually variables, but the decompiler doesn't know that based on the assembly that's produced. These things will produce equivalent assembly. And it's good to watch how things change. For example, we're at 90.20% similar. We want to get to 100. If I remove that variable and do the assignment directly, that gets us to 91.97, so almost 92%. So it got us 2% closer to being at the end by getting rid of that variable. Finally, this temp v1, this is going to be something similar, where instead of using the variable, we'll just use that value inline. That didn't change the code percentage at all, or the similarity, but it's most likely the way that it was. The other thing that I like to get rid of early on, if I can, are these go-to statements. In this case, this particular condition is jumping to destroy entity, and then the function is returning. We can put that up here and do the return, allowing us to get rid of that. And finally, I know from yesterday, this is a very similar function from yesterday, that these are going to be set outside of this. Looks like it's us a little closer. Not quite there yet, 92.24. But the code is cleaner. Another thing similar to the player macro changes, GAPI is a struct. When Splat64 is extracting, it's going to take symbols that are mapped and put those direct symbols in, but GAPI isn't. GAPI is a struct, and we're accessing these through struct fields rather than directly, so those will all get changed to field access. And that got us a little closer as well. So as memory access changes, whether it's array, indexing, field access, direct access to some symbol that has a memory address in it, that changes how the compiler will load those values. All right, so we're at 93%. Scrolling through. So early on, we have a jump to the destroy entity function. I'm going to come back to that because that might fall out. Ours is down here. We'll come back to that. The other thing I'm going to do just during this cleanup phase is get rid of as many of these casts as possible. Those are also noise usually. Of course, the day that I had chat, there's lots of questionable things in chat. All right, let's keep going. So one interesting thing that happens quite a bit is palette and flags are set out of order. Reordering those gets us a little closer. And so we're really just left with this destroy entity. Let's try moving that up and see if that resolves that. It does not. So what is going on here? So the check is being done, but then this branch is happening much later than expected. Let's pull this out and see if this is not part of this block. And that's what that was. So sometimes where the decompiler puts conditional logic boundaries is also incorrect. So that straightened most of that out. And it looks like what's left is immediate values. There's misordering here. That fixed that. So this I'm doing in the wrong order. That fixed that. So now we're at 99%. That looks pretty good. So there are immediate values that are wrong. This is pretty common in decomp.me because when the assembly code is being extracted, it's assigning addresses that are known that other developers have found and put into that configuration. Many of these things are being accessed through struct offsets, which are computed addresses. So based on some known value, what is an offset into that struct? So that known value plus a 14. When the assembler takes this code and converts it into machine code, it'll resolve those addresses and they'll come out as the same thing. Decomp.me doesn't have any of that context though. So it doesn't know that G entity is how it's related to this player symbol that's pulled out, because none of that information is in decomp.me. All right, so we have a mostly matching function. This is usually a good time to see is this going to work as is. So we're going to copy this. There's definitely some things that still need to be updated here, but this may be close and matching. So we'll go through and compile that in. And yeah, that is a match. Great. So we're not done yet though. We have a lot of magic numbers. We have things that need to be wrapped for portability. So we're going to go through and do all those things now. So the way that entity access works, there's a bunch of common entity fields. Then there's this extension, which is a blob, and depending on the type of entity it is, different structs in a union are used to pull out that data. This particular field looks like it is going to be the player animation. So we're looking for a range. Where is the player in its animation cycle versus the weapon in its animation cycle? I should have pointed out that this is the Basilard weapon that we're decompiling. This animation set, this is something that is provided in the weapon overlay. So we are going to use the overlay macro to assign that value. The palette is something that's coming from the main game engine. Sorry, that's flags. These are both going to be unknown flags. Oh, this is not. I may have too many zeros in there. We'll see. Too few zeros. Too many zeros. So params we're masking. I don't think there are any macros or defines there. Step, we're gonna change that to an increment operator. Down here we're gonna do player animation. This stub extension, so this is offset 30. We're gonna be using the weapon portion of that union, and offset 30 is it's probably that, yes, that same field. Getting rid of superfluous parentheses. Same thing here with the weapon animation. And there we go. So to give a quick overview of what the function is doing, so a lot of decompiling is getting the code to match what the original assembly said. Sometimes I go through this very mechanically and don't even think about what the function might be doing. Sometimes it helps to understand what the function is doing as well, because some assembly doesn't match, and you're just trying to bang away at what operation should I be doing, what variables, what fields should I be accessing. But it's also good to understand what the logic of this function is as well, because then that can help you decompile and maybe get the logic right, but not matching the assembly. But then once the logic is in place, you can go back through and finesse it to match the assembly as well. My interpretation of this is when the Bastillard is attacking, we're going to look for where the player is within its animation, and we have a range within the configuration of the Bastillard to start animating within that configuration. So sometime between that frame start and 7 frames later. If that's the case, then we're at, and we haven't run yet, so we're at step 0. We're going to pull in the sprites, set the palette, basically do all the setup stuff, and then set our weapon properties and move on to the next state in the Bastillard state machine. Most of the entities are based on the idea of a state machine, and kind of go through the same pattern where we're going to do one thing and we're either going to wait until some other event happens and move on to the next state, or we're going to do our work and then move on to the next state. So we're still within the first 7 frames. We're updating our animation frame along with where the player animation is. If we're if the current player animation duration is 1, my guess is that that is 1 frame remaining, and we're at the sound frame of our animation. Then we're going to play the sound effect. Again, that's happening within those first 7 frames. If I haven't looked into the unarmed animation, I'm not sure what that check specifically is for, but basically, if we're in unarmed, this object is going to be destroyed. It's a little funny, though, that that happens so late in this check. If all of this happened, we're not within the 7th frame, we're going to destroy the weapon. It's not destroying the weapon in game logic, it's destroying it in render logic. Otherwise, we're just going to go through, set what the hitbox is for that weapon. So in this case, we're basically setting the weapon so that it has a hitbox, and then doing setting the drawing flags for that weapon. All right, so this is a match. Like I said, the decomp.me doesn't know about our offsets. We're going to mark that as a match override. Yay, we finished. We'll save that. We're going to go back through and copy our source code back into the project. We don't need the ASM include anymore. And then make sure that the built object still matches the PlayStation retail release. I haven't set up a branch for this yet, so we're gonna set up a new branch. First we'll rebase on the main Git repo. So we're doing weapon 31, and this is anti-weapon attack. So we're going to make sure that our change is what we expect, getting rid of the include ASM. There's one additional thing I'm going to change in here before committing this. I guess we can stage it. Sorry. I hope if I pull what I'm doing here. So this this sprite part offset is sprites that are symbol is provided for them at build time. It's called anim set, so we're going to replace that. I'm actually going to clean this, extract those objects from the retail release, and build again. And this will make sure that the build is clean and our weapon object still matches the one from the retail game. Okay, it does. So we got rid of our sprite parts using the global. So we have a stage file ready to commit. We're going to call that 31. All right. The next thing prior to submitting this for a pull request is to run the linter and make sure that the code that we're going to be submitting for review matches the project's coding standards. I'm not going to worry about this at the moment. So there's a few coding conventions that I like. That Clang format, their default for C++ projects, which is what this project uses, are a little different. I looked into this yesterday. We had a conversation on Discord about it. What can change? There's some places where formatting is turned off because when you're aligning struct definitions and other things like that, there's patterns that make things easier to read, but Clang format by default doesn't necessarily use those. Turning those settings on or off in Clang format introduces other problems when I was looking into it. So I'm happy with the way the settings are. It's just not my default for when I'm writing the code. So I'm going to see what it changed. And basically, it just took this this one conditional and moved those onto the same line, and that's fine. That doesn't bother me too much. So we'll add that, and we'll amend that commit. And then we're going to send it to GitHub. And go back to a browser. Where GitHub already has our commit waiting for a pull request. This is a pretty straightforward decompile. Usually if there's something that I'm refactoring or something more involved, I'll try to write a nice description. This description is what goes into the commit message, so it should be something useful to people in the future who want to figure out what this is. In this case, it's a pretty straightforward decompile. There's not much interesting to say about it that people working on the project would need to know. I take this time as well to go through and see if there's anything obvious that a reviewer is going to find. Yesterday, we got our PR right away, and I had some comments that I was able to fix. I don't see anything super obvious. But we will see if any of this comes back. All right, so we'll create the pull request. And when the pull request is created, it's going to do a bunch of automated checks to make sure that code formatting is correct. We ran that beforehand, so that should pass fine. And it's going to make sure that it compiles with different versions of the game that have been extracted so far. So the PlayStation version, PSP version. PlayStation version right now is the only one that's compiling weapon objects and doing a comparison. When the PSP version comes in, it's likely that some of this code will need to be tweaked slightly to match there. The PSP used a different compiler, so it has it introduces additional information for types, for code structure, and other things like that that we don't necessarily have when compiling using GCC for the PlayStation 1. But that'll go and build, and we'll wait for a PR. Yesterday, Dynamo was kind enough to give us a PR right away, and so that code has been checked in already. And so now, basically, we're just waiting and hopefully being good contributors. So we finished that in about 50 minutes. We could do another weapon function, or we could move on to something completely different. So let's see what else there might be. we'll go through. So when I'm looking for functions to decompile, there's a couple things that I'll do. I'll look at this duplicate list. Fortunately, many of the duplicates have been matched. So stages, weapons, different parts of the code reuse a lot of the same code, whether that was originally through linking precompiled objects. In some cases, it's copy, paste, and tweaking code that's from different things. There's a lot of, we'll say, reuse, aka duplication, within each of these objects. And so this list is to help find those things. In these cases, when this column on the left says true, that means it's been decompiled already. There's nothing more to do there. And so there's not really a lot on the duplication list that's left. I know that there's some in NO3 that still need to be mapped. And there are some weapons that are very similar, where if we decompile one of them, especially like this weapon 53 and 56, decompiling one probably gets us almost all the way to the other one as well. And 56 and 54 are similar, so decompiling one of those mostly gets you all three. The other place that's worth looking for new work is in the wiki. There is now I'm not going to be able to find it, near matching function scratches. So these are, not that wiki. Of course, now I'm not finding it. There is a wiki page, though, that has a list of functions. Is it this one? Yes. A list of functions that are have not been decompiled yet, but may be relatively close. And so we can look here and see. So this init ring status in libcd, there's a scratch, somebody has worked on it, and it's 0.75 of the way there. And we're missing, we have an extra store when normally there's no op. I'm guessing if you get rid of this, something else is going to break, of course. This U32 pointer isn't being assigned. I would need more context on this function. This is part of the CD library that was part of the PlayStation 1 SDK. For something like this, I'd go back and read the docs, see what it's supposed to do, and then see if that gives me any context. Let's see if there's anything else outside of there. So a function in st0, I thought st0 was done. Oh no, the prologue is not done. So there's actually a lot in the prologue that still needs to be done. So we won't be able to finish one, but let's find something in there. Different people work different ways. Sometimes it's useful to look at scratches other people have done. Sometimes putting your shoes into the developers of the original PlayStation version and then putting your shoes into the mindset of a decompiler can be difficult, at least for me. So I'll often look at other people's scratches if they're in the process and I haven't made any progress or I'm stuck in a certain place, but I usually like to start fresh and then work from there. But we can go and see if we can find something in st0. So we'll look in the ASM directory again, the US version, ST, which is stage prefix, ST0, we're looking for non-matching, S files, and we're going to do the same thing where we sort by the size and see if there's anything. Anything small, and there's still some relatively small things in here. Small does not mean simple, as seen by that that init lock function earlier. Very small, but there's just something off about it that is not obvious. I'll mention the memmove function again. I spent a couple days working on memmove. Again, very simple function. There's lots of different implementations of memmove in a lot of different operating systems. But the PS1 SDK version is slightly different than all of them. And so you get an idea that it's going to work one way, and then it ends up working a different way, whether that's how memory is accessed through an incrementing pointer or through array access into a fixed pointer. And that can mess with the direction you want to go for your implementation. So first I'm going to look to see if entity lock camera is anywhere else. So there is an implementation, and my guess is that this is probably for the PSP version. Oh, it's a partial implementation that has been done. Okay. So in some cases, it's useful to have an implementation in place, even though it might not match perfectly with what the original code did, if you're looking to target maybe not an original platform, let's say. So we can look at that one. So I'm going to do the same thing that I did earlier. Start a new scratch in decom.me. This time, though, I am going to go back and create a context because I have a file where a lot of other definitions, my context probably includes most of these, but it's nice just to have documentation of how this works. So I'm actually going to use this this implementation so to use the context generation target, we specify source, percent in vim is going to expand to the current file. So I'm setting the source variable, and I'm going to make the context. It generated one. There's a warning. Not too concerned about that. It creates a file called ctx.c. Off screen, I'm going to get that file. Normally I would copy this into the context, but for these stages it includes a lot of code as well. Let's do this. I don't think I care about the sound effects. Let's set the source to st0.h. create a context for me. Get the right directory. That might work. Great. Off screen, I'm copying this to a buffer. This might be useful, it might not be, we'll see. So there are a bunch of things that I didn't find. Let's make sure that this function signature is correct. So in the code it says it returns a bool. I believe, oops. These other vars were known to the previous decompiler. And then these tile maps are going to be similar to the player variables from before. We have a bunch of errors. So when creating a new context, this happens quite a bit. So we're going to disable built-ins. It doesn't like something on 1789. So in this case, we're using an entity here, a reference to an entity before we define what the entity is. So I move that up here. Nope. I put a declaration here. You'll get your struct entity one day. And standard C hosted, get rid of that. All right, so now we can go back to our source and start pulling these things out. Offset 30 in an entity is a params. Usually the decompiler figures that one out. We can actually try to decompile this one more time. With the right signature. No, it still didn't take that. That's bizarre. Okay. So here we have array access. Is this one of the ones that we have done here? We don't have. So here we have an unknown type for this pointer. We're kind of going to go backwards and figure out the types of each of these until we can get back to what these might be. It looks like a pairs of maybe points. So on this line we're multiplying, so we have some index temp S1. We're taking that index and multiplying it by 4, which means we have an index into some 32-bit value. And then we're multiplying that by 2, which looks like pairs of 32-bit values, or quads of 16-bit values. So we know that this is or the previous compiler or decompiler, human, thought this was an array of unsigned 16s, which is likely, I'm going to see if this is being used anywhere else, which would give us a hint as to so it is that same, it's in the same file, it's that same funny access. We probably can figure out a little more about this and define that a little more specifically. It's also good to look at the shape of this in how it's been extracted as well. So we can go to the disassembled data and get a sense for what the size of that is, what the values are. So we have something pretty small, but like I said, it looks like pairs of 16-bit values grouped into sets of 2. So it's possibly a rect or just pairs of points. If we look at what a rect looks like. So this is a quad of shorts, starting point of 0, 0, ending point of OX500, OX200. That's possible. We'll go with that until that assumption fails. The 500 in hex seems a little big. That's 1280. So to have, we'll try it. We'll try it and see. So instead of a U16, we're going to say that that's an array of recs. And then if that is an array of recs, then tempv1, 2 is going to be a pointer to recs. And tempv1, 3 is going to be an offset halfway into that, which is fine. Oh no, it's going to be offset into the Y field, and then an offset into the width. That does match this, so this would be X. This would be Y. This would be width and height. If I would read the code beforehand, I would get all these hints, and I wouldn't have to redo all this work that the decompiler already did for me. Boo. That's okay. It's there. Line 60. We don't know what that is yet. Same thing. So we'll just reuse that same rect. We'll just rename this rect. So there's a slight change based on the direction, or the way that the setting of the timer. I'm going to try to get away with just adding that to the index, and we'll see if that. All right, compiling, 75%. We'll go through and do all of our struct access. Reset our name. Params is being used as a 16-bit offset into this index. I think we got rid of a bunch of these variables along the way, so we can get rid of those as well. Oh, it did not like that at all. So I'm not talking through a lot of this. Trying to understand how or why params is a funny field in entities. It's often used for lots of different um, flags and other things, but often some of the bits are used for data, and those bits are shifted in interesting and weird ways, and depending on the entity, they're used for different things. It's kind of a entities have an extension field, which is a blob that's used again depending on how they are, but usually that data is structured. This is more like a bit packed version of custom data specifically for an entity, and so how it's used differs depending on the entity. And I'm just trying different things. Usually there's shifts, usually there's masks to figure out how to access it. In this case, oddly, it's loaded as a byte, even though the field is I think it's a 16-bit value. Yeah, it's a 16-bit value. So we're only looking at the first 8 bits, but then later on, it's being masked as a 16-bit value, which isn't obvious. That's possibly because it's not reassigned. It's just used directly as no. Okay. I'll come back to that one later because that it's probably straightforward, but not obvious to me right now. So on line 23, we have these out of order loading. This temp v0, we don't know what this is at this point, but we can go look at that data. I'm assuming that this gets set somewhere else, but in when it's initialized, these are all zeros, so our offset that's being pulled is always going to be 0. Like I said, it's probably being changed somewhere else. All right, so let's keep going down. So we're back here with params. Params is already an unsigned 16. Again with this odd params access. Let's try to get this into a 32. Up here we're going to so we can force that into a 32. Down here now, can we use that directly? No. That doesn't help. So this is being delayed. Strange. I'm going to come back to this and we'll see if this doesn't work itself out in other ways. This is likely why others gave up on it, but I'm not that smart. Or maybe I'm too stubborn. Okay, so originally I was accessing this as a rect, and that's how we're loading it. This wants an unsigned value. But this is treating it as an array. This happens often as well. You'll have structured data, but the code wants to treat it as arrays of 16 bits or arrays of typically signed 16-bit. So let's try that. Okay, so we have wrong registers. Okay, so it is treating it as, it looks like, just an offset into this. Into this address. And it looks like it's following this pattern. Which I guess allows it to index anywhere in there that it wants. But why? I don't know. before I continue on. This, how params is being used is going to continue to be an issue. This down here is likely the same idiom. This actually might be a good time to talk about the decomp permuter. As fun as it is to go through and try all these different variations, and I mean, we're getting really close, 92%. What was the original? So we were... So we have one at 96% already. And we might peek at that to see where things might be going wrong. But until then, let's continue on a bit longer. We can talk about the decomp permuter while looking at that other one, or have the permuter going. Oh, I did something that screwed things up. It really likes that cast. In this case, though, we're just comparing against 0. I should be able to get rid of all that. Make sure that is an unsigned comparison with 0. Bizarre. All right. So sometimes you get into a pickle. This one we have other resources we could go look to see what they are. And that's probably what I would do if I was aggressively trying to decompile this. But since this is for fun, I'm going to copy this into the source that it was from. And we're going to store this. And so we're going to put our function in there. And I expect this to compile, but to not match. Oh, drat. The formatter... is it the formatter that ran? What is it upset about? Okay, so we failed ST0. That's expected. Normally this isn't as far along as I would get it before running the decomp permuter, but it's a fun tool to show. So as a human, I can go through and I can do about a dozen or so tweaks to this code a minute, but the decomp permuter can go through and maybe not as intelligently, but it can go through and do several hundred, if not thousands per minute. Um, so I'm going to import that file, which is 27D64. I'm going to tell the importer where this assembly is. And then the permuter is going to go through and it's going to try lots of different variations. To see if there's any tweaks that would make this code compile more similarly to the original assembly. And it's already found some. So what we're trying to do is get our score down to 0 or as close to 0 as possible, which increases the percentage as close to 100 as possible. And so it's found some things that would be better than what I have so far. So we can look at what those are. And we'll look at the best one first. Sometimes these give you good hints. Other times they don't. So the decompiler actually figured this out originally, and I dismissed it because I didn't like some of the masks that were being done. But this says if I go back to an 8-bit value for params, that will get closer. So let's try that. So we're going to go back there, and then it also wants this to be reordered. That actually got us much closer. So it wants basically the multiplication happen in the other direction, and so that's fun to see. And sometimes you can tell from the assembly that that's what's going to happen. But if we watch the score, we're just going to take the multiply by 4 and move it to the other side. And did that get us closer? It didn't get us closer. I thought it did. So that doesn't matter. All right. There is another shift that's happening down below, which is a multiply by 8. And then let's try masking this whole thing. It doesn't make a difference. Oddly, however, yeah, that shift is already happening. It's just out of order. Let's try. So registers are wrong here, but everything else looks fine. We can move this inline. And that isn't doing the mask. It's doing everything else though. We'll keep that there. Likely not correct, but closer. So now we're a little closer. So the decomp liked that was, or found that the compiler likes that was a 8-bit value, and so that gave us some improvement. It's found other things along the way too. It found another one that we can look at. Basically, this is just giving us hints as to where code might need to be changed along the way. It wants this params to be a short in this case, and that's the issue, is that params is being used a lot of different ways. So if we change that to a 16, so that gets us slightly closer. So it's going to fix some areas, and actually, did it give us that mask for free? No, maybe not. Fixes some areas, but not others. That is closer though, and we're approaching where the other decompile was. I'm going to stop the permuter, seed it with the updated version of this function. I'm also going to tell it to focus on this area, just in case it's trying to tweak any of these other functions. I'm not sure how intelligent the permuter is, whether it looks at the symbols that are in the original disassembly or not. But then I'll restart, and so we have a better base score, 425, and so this will run. Sometimes I let this run for quite a while I go off and do other things. Some cases like this, it found a change that's going to produce the same output. It found something slightly better now. We'll take a look at that. So it thinks that we can mask this, and that mask will show up. RV1. So this wants to use varv1. However, varv1 has not been set at this point, so we know that code isn't correct, but it's possible that is the field that's being used. Yeah, it's not. Well, it's also possible that there are several variables set to this. We found another one, 365. Let's look at that. In these cases, effectively what it's saying is, I want you to reuse this variable because the registers that are being assigned to that variable are being used here. And sometimes that helps. So the convention that in this project seemed to suggest that developers were very judicious about reducing the number of variables that they declared in functions. So something like this, where there's even 8 declared at the top, is unlikely that this was originally this way. So we could try to start getting rid of some of these things and see if that helps. Sometimes it does, and it's just not obvious right away, and that can be challenging. Let's see if I found a 255. Before we move on to that, let's see what that is. So the permitter's running, doing its thing, finding different things. We'll look at what the difference is for that. This is another one of those cases. So it seems like there was not a separate variable being used here. This was likely just being reassigned to params. The major issue is params right now is an 8-bit value, so masking it against a 16 does not do anything. I am happy to go down that road, though. All right, where did I screw up before? So that's not getting this closer. Let's try one more time. So this is going to be params equals RV1. There's params here. And we could try it their way. Yeah, okay, so that does work. So we should just be able to set params, though, equal to this. It would be equivalent, but it's not. We do have an unnecessary mask because we're converting this 32-bit down to an 8-bit. 8-bit value. Does that make any difference? No. No, that's... so these definitely are not correct. All right, I'm done tweaking that for now. We'll go back and see if the permuter has done anything interesting. It has not. We'll go through though and reseed with this. So we reseeded with what was in decomp.me. We're getting close, down to 205. Often there's suggestions like this, which is pulling things out into new variables and then doing some tricks with those new variables. And basically it's trying to coerce registers to behaving a certain way. A better way, in my experience, to coerce registers to behave particular ways is to figure out the right variables and right types that need to be used. And so this will take a little more tweaking. I'm probably not going to continue to work on this at the moment. But we'll save it and maybe come back to it at some later point. It's pretty close. It should be finishable in another 30 minutes or so. All right. So if you're interested in decompiling and want to get involved, or if you want to see what it takes to decompile a project, so in this case it's PlayStation, PSP, it's actually fun that it's a multi-platform project because that code is coming, assembly code is coming from a lot of different places. For the most part, it decompiles into the same source code. If you're interested in any of this, if you're just interested in Castlevania, Castlevania development, modding, things like that, you can start at soten.z.dev. There's a link to Discord there where people are talking about decompiling this project. If you're interested in speedrunning and other mods, There is also long library, where a lot of people are talking about Soten Randomizer. My hope is that as this project progresses, one of the things that I've been thinking about doing recently is taking some of the randomized objects and doing decompiles on those, and so we can see um, in the past when people are doing direct binary manipulation and patching for their randomization, going to specific memory addresses to change attribute items and things like that. What happens if we pull that back into C code and we could run a randomizer that's manipulating code instead of manipulating just memory addresses? So soten.z.dev, there is a GitHub project, which is the Soten Decomp GitHub project. More information there. If there's any questions or if people want to know more or have me focus on a certain area during a live stream, I'm happy to wade into any area. I might not make any particular progress, or I might just be figuring out things and going through my thought process. Feel free to reach out, comment, like, subscribe, all the other good things that people do on streaming channels. I have been posting these up on YouTube as well, so I will publish the replays. Mostly they're just the same thing, going through a single function, going through the decompile process, and more about the software process, finding some work to do, doing that work, and then contributing back to the project. If people want to see other things, decompiling data, there's other people that are working on a lot of the data decompilation at the moment. I'm happy to look into those areas. I've been focusing on weapons because there's a lot of work to do. They're pretty straightforward functions that all decompile to the same thing, so I know that I can get success there by the end of a 1 or 1.5 hour stream. But I'm happy to do things that like this, where I don't know if I'm gonna succeed or fail, but just go through some of the tools along the way. Anyway, thanks for watching. Like, subscribe, send feedback, and if you want to show up on Discord, there's a lot of people chatting there. See you. This is Thursday, so I'll be back on Monday.